This
What's
is
the total?
lab 8 capacitors.
What's the total capacitance going to be?
Is it 1 over C1 plus 1 over C?
In series, yeah. So there's
Yeah.
it's the opposite of resistors, right?
Yeah.
So in resistance, you add them. When you put them in series, you just add the resistances.
Right.
Capacitors, when you put them in series, you take the inverse of 1 over. So it's like 1 over C total is equal to 1 over C1 plus 1 over C2. Right. So C total is this thing.
Okay.
Right. Okay. So in this lab, we were basically just trying to like see how they behave when you put them in the circuit, right? And so we use the this is DC, so we use the AC power supplies, and we use the oscilloscopes to look at them, right? So what are capacitors actually?
They store energy.
Yeah, they store energy. So they're basically two plates with something in between, right? And what happens is when you put them in a circuit, you'll have positive charges over here and negative charges over there, depending on. So if the circuit's going like that, you have positive on one plate and negative on the other plate, and you basically open your circuit, right? But because as long as you have this thing powered up, they're going to stay like that, and it takes energy to put them like that, right? So you're storing all the energy it took to put them like that in that capacitor. Okay. So when you turn off the circuit, when you turn off your power supply, then these will discharge. Okay. So then if you have like a light bulb here, then if you when you turn this on, your light bulb will slowly dim because this is getting, you get less and less current through the circuit over time. And when you turn it off, your light bulb will slowly, this will basically release all of the charge and it'll go through your circuit again. So we were using the AC power source, because we basically are going to turn it on and then turn it off, turn it on, turn it off. So this capacitor is going to charge and discharge and charge and discharge. And that's what we were seeing on the screen of the oscilloscope when you got the pattern that looked like this, right? Okay, so then basically we were trying to look at the behavior of this in the oscilloscope and find, since it's exponential, we know it's exponential, we were trying to calculate a half-life, right? So if this is time, and then this is voltage, which is what you're looking at over the oscilloscope, you set it to like 8 max, and the half-life is defined as the time it takes to get to 4 volts, right? And so that's the equation that our capacitor follows, right? So we wanted to calculate the capacitance of our capacitor from this curve, right? That was like the second part of the lab. So there's not much circuit building or anything in this.
What
It's already built.
about the hookup of things?
To the oscilloscope?
Yeah.
Yeah, we don't have an oscilloscope, so I can't go over that. But you have two different. The oscilloscope has 2 different inputs, right? So you use one of them to get the voltage across it. So you see this, and then you use the other input to just get the behavior across your capacitor, and there you see this.
Is it just across one capacitor that we're looking for, or both? So it would be set like that, or
No, just one.
just one? Okay.
Just one. And then what you can do is you can put them in series and parallel and see how that affects the half-life, which was the second part. But once you get the RC part of it, this will just change your curve. So if you, I think if you put them in series, you get a shorter half-life. In parallel, you get a longer. Okay, so we're trying to calculate C based on this curve, right? And usually we try to find some linear. Right. So two different like takeaways from this lab. One is this curve, like how do capacitors work and measuring them and everything. The other one is like linearizing. How do we get some relationship? How do we find C if we don't have a linear relationship between these two things, right? So we have an exponential relationship between V and T, but we want a linear relationship, right? Because we want to calculate this. Right now this is in the exponential. So what do we do? So if you,
Take ln of the equation.
right, right, if you take ln of these sides, and then I think it's some log with a negative. I think it's ln of v over
So that it'll switch.
v naught equals negative ln of v naught over v, right? Because this is ln v minus ln v0, right? And yeah, so right, so right, and then RC. Or T. So T equals RC ln V0 over V. So now we have T. Now if we take this as our x, right? We have a linear relationship. So we can plot time. So when you're finding half-life, you're finding time as a function of voltage, right? So you want to find what time corresponds to 4 volts.
So is the product of RC the slope?
Yeah, so the slope, so if so this is t, and so you have ln. So this is your linearized variable, right? So v was our unlinearized variable. Ln of v0 over v is our linearized variable in time. And now we get a plot like this. So the slope is going to be t over ln of v over v, right? And so c is equal to slope over r. Do you see that? So that's how you can find c from a curve.
Okay.
Okay.